Hello, I am Verdi Arbusto, and this is the Schumann Resonance Harmonics channel on YouTube and Facebook. Occasionally, I'm working to, kind of cohere those two. I've done a general introduction on this video, and so what the place of this is and why I'm doing it. Okay, so please find that the link to it is in hopefully the description. This is intended to be a lesson length, which means up to 33 minutes. And I'm probably going to go right up to the 33-minute mark. 3 minutes for a little buffer on either side for my jabbering. Um, but I'm going to give a little more specific introduction to this particular, out of its context of what the series is and why it's a little bit more relevant to me personally, I guess. And to one of the, I'm forgetting where, it was either YouTube or Facebook, I forget which. Someone had asked a comment about the Chinese rocket that had recently blown up. And so so I answered that. In general, this video deals with that particular issue of a rocket blowing up or a bomb going off. So, in a nutshell, when I was asked about the 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 rocket explosion, my response is, yeah, it'll show up on the Schumann somehow, but it's not because the explosion interferes with the ionosphere in some way. That's how it would cause some type of a reaction on the graphs. So my first reaction is it of itself is not going the explosion of itself is not what is going to be shown on the Schumann resonance because it's an acoustic wave, sound wave, it's a pressure wave. So there is a difference, I said, if it were to be like a nuclear explosion, nuclear bomb, because that leaves a radio signature. Okay. Because of what that is, that's a different type of explosion. So if it's just a simple mechanical, chemical transition of the fuel into an explosion, that's a mechanical, like I said, mechanical, chemical kind of, transformation. That's one thing. That in itself wouldn't show up. The effect on the ionosphere, different matter, that's what shows up. Okay, related, but it's it's a part of it, a byproduct of it. And again, this wasn't that type of explosion. So essentially, this deals with that question of, or the issue of this particular website, unbeknownst to me, of that general issue, the general topic of an explosion in the atmosphere. Okay, so let me get into the material. All right, so I think that was a little introduction enough, I think. Uh, infrasound in atmosphere and its connection with space and geospheric processes by Soroka, S.A., Kalima, et al. Rest. These are Ukrainian folks. The LV, that's funny. You look at it, it looks like Lvov, Center for the Institute of Space Research, uh, NSA, NSA-NAS of Ukraine, blah, blah, blah. All right. Infrasound fluctuation in the Earth atmosphere resulted from the action of numerous geospheric processes and processes in near space. Action of the energy of a space origin on the Earth processes is usually connected to electromagnetic radiations and solar corpuscle flows. That is a mouthful. The integration of electromagnetic radiation with heterogeneities of the atmosphere transparency can result in generation of acoustic fluctuations in a wide range of frequencies. It is important to note that the transparency heterogeneities of the atmosphere are significantly determined by solar activity, and they give the abbreviation SA. One can expect that in the spectrum of the infrasound fluctuations of the atmosphere, and that's an abbreviation IFA, that's infrasound fluctuations of the atmosphere, IFA, the SA, solar activity, rhythmic should be manifested. Okay, and this is translated, so I work through these the best I can. As long as I think to myself, as long as I can string this all together, not fumble over it too much, and just get through the sentence, I'll be okay. You can read it yourself. Hopefully, I didn't mangle it up too much for you. It's translated. I do my best. Thank you for your love and support. And remember, like, share, comment, and subscribe. If you're new here, welcome. Share and share often. One can expect that in the spectrum of the infrasound fluctuations of the atmosphere, or rather FA, and the SA solar activity rhythmic should be manifested. The widely known connection of SA with, I just want to say it, solar activity. I think I'm just going to read it without abbreviating it. So, with biospheric processes can occur through the acoustic channel. Okay, the widely known connection of solar activity with biospheric processes can occur through the acoustic channel. Okay, what is the acoustic channel? They give us some references. I think they mean the acoustic ability, perhaps, when they measure amplitude and the dependencies, amplitude and quality. They call that a channel. They refer to it as a channel. It takes up one, if you had, like, on your stereo, you have two channels. So you have a left and a right. There's a positive and a negative, right? So you have two wires, but each channel, there's two wires in a channel, but each channel has, one sound, one, how do I say it? Not one sound, it's one, each channel is one dedicated circuit. Stereo is two signals, left and a right. That's two channels. Okay, so amplitude is a channel, and that's so relative to the measuring, Mr. Measurer here, Mr. Measurement. Acoustic channel just means the way that they're picking up the acoustic wave, if you will. Like on a speaker, a loudspeaker is an acoustic channel. Okay, so I'm looking at my speaker, that is an acoustic channel. I think so for the purposes of what we're looking at here, that's what acoustic channel means. Each dependency is a channel. I think that's another way to look at it. Hopefully that makes sense. The intersound fluctuations in the atmosphere, IFA, are caused by seismic activity. Maybe I'll just abbreviate that one. Caused by seismic activity. All right. In this case, it is possible to consider two situations. The IFA can be both the external influence on preparatory processes and the result. Well, that's interesting. The infrasound fluctuations can be the external influence on preparatory processes and their results. All right, so that's sort of what the Schumann resonances are, in a sense. I'm not sure if that's exactly one-to-one, because the originating waves that cause the Schumann resonance circles around. I explain this to people. It's a resonance is a wave that keeps repeating over and over around, and then it bumps into itself. So you get the interference with itself. And so in a sense, that's what the general, I'm not sure if it's one-to-one correlation, but that's a general way to look at it as well, that it's an influence and it's also the result. Okay, the light at 8 hertz is the fundamental. And so that is the cause, the initiating force the lightning. And then it is also, as it travels around, it also interferes with itself, and it's the result. I'm not sure if that's exactly one-to-one, but I'm interpreting that. Hopefully I'm not mistaken. All right. It is known that the intensity of seismic processes is caused by solar activity. This connection was found during the analysis of global seismicity on the Earth and the 11-year cycles of solar activity. It is considered that this connection occurs through cyclonic activity in the atmosphere. Cyclone, I believe. However, it is possible to assume that solar activity influences the intensity of the infrasound waves in the atmosphere, which in turn influence the seismic processes. And seismic meaning movement of the Earth. Thus, the Sun, interplanetary environment, atmosphere, and lithosphere represent a uniform system in which the infrasonic waves play an essential role during interaction of geospheres. Okay. When I read it, I also want it to make sense. So I don't just read it dumbly through. I need to kind of understand, and that's how I know sometimes it doesn't, the words aren't always translated, like I would normally have been used to. But whatever, it's all language. I work through it. I get a general gist of what they're doing. In LCISR, the researches are carried out in 3 directions. Okay, so we have researches of the influence of solar activity on infrasonic fluctuations in the Earth atmosphere. Next is researches of connection of seismic activity with infrasound in the environment. Okay. And the last is researches of the influence of artificial acoustic disturbance on the atmosphere, which is the ionosphere system. Oh, that's a mouthful. And I think that's what the rocket would fall under, the artificial acoustic disturbance of the atmosphere. The purpose of the first direction researches was the search of rhythmic solar activity in the atmospheric infrasound spectrum. As a result of the analysis of the infrasound spectrum for the period of 1997 to 2000, the annual, seasonal, and 27 daily periods of fluctuations were found out. The hypothesis about the increase in infrasound energy with reduction of solar activity was confirmed. The diagram of the influence mechanism of SA on IFA was proposed. Within the framework of the second direction, the researches of infrasound changes before large earthquakes and after them are carried out. If to assume that the preparation of large earthquake is accompanied by small changes in seismic activity on the large territory, these changes will not be noticeable during seismic measurements at one point. In IFA, the large changes due to their integrated character and due to the dependence on many factors accompanying preparation of earthquakes on the large territories can be observed. The characteristic changes of the spectrum and phase diagrams of infrasonic fluctuations in the atmosphere before large earthquakes are found out as a result of the carried out researches. When performing researches in the third direction, the numerous experiments on observance of the electromagnetic responses on acoustic disturbance in the atmosphere are carried out, reference 4, as a result of use of mobile acoustic radiator, the effect of increase in acoustic disturbance in the atmosphere was found, reference 5. The connection of infrasound with geomagnetic variations was experimentally proved. Okay, was proved. Okay, all right. Let's take a pause break here so I can have a cup of coffee. Good place to pause for you if you need to do the dishes or whatever. We're halfway through this. Okay, meet you on the other side. Okay, we're back. Welcome back. Infrasonic waves in the atmosphere and solar activity. It is possible, where am I? It's possible to name some sources of energy of a space origin, including acoustic fluctuations in the Earth atmosphere. They are the gravitational influence of the moon and the sun and fall of meteors, etc. The reaches of connection of IFA and SA were carried out, proceeding from this fact that the maximal values of infrasound amplitudes were observed at the moment of SA decrease, solar activity decrease. The hypothesis was put forward that the infrasound level in the atmosphere depends on galactic cosmic rays. Good God, this is a mouthful. All right. The hypothesis was put forward that the infrasound level in the atmosphere depends on galactic cosmic rays. GCR. Oh, good God. Can I escape those? Can I ever escape those? The cosmic rays. No, they're really a thing. They're actually a thing. All right. They're not just, Marvel Comics. Cosmic rays are a thing. They're here with us. They were here before, but we're detecting them now. So all of a sudden, oh, they're a thing, but they've always been there. They're more of a thing now that you can read about them. All right. So they're giving us, anyway, shut up. Get on with the material. So they're giving us here this graph, this fun graph from the years. Infrasound is the red, it's going down, apparently. The solar activity that's going up. 11-year solar cycle. We just entered 26. In November of last year, the end of last year, we entered solar cycle 26 officially. All right. So as the sun cycles go up and down, the diurnal process goes up and down. You see fluctuation of these thingies here. All right. All right. So, all right. All right. So let me show you. Actually, maybe let's just read this in. Figure 1. Let's see what we read. All right. What are we looking at? Don't just flip through. What are we looking at? All right. Figure 1. The changes of annual energy of the infrasound and solar activity for the period of 1997 to 2000 are shown. The maximal annual energy of the infrasound was observed in 1997 when solar activity was minimal. Well, look at that. Well, I'll be dipped. As the solar activity goes down, the infrasound waves go up. Well, that's interesting indeed. Okay. Similar was observed during the short term, and it's 5 to 10 days, changes of solar amplitude. Solar activity. Solar amplitude. It kind of is. All right. The infrasound measurements were carried out at the Western Regional Center of the Special Control NSAU at a point with coordinates 48 degrees north and then 20 seconds? I don't know. 26 degrees east. All right. The connection of SA. The connection of SA with infrastructure in the atmosphere can be presented. All right, this is a great graphic. I want to show you this, guys, while they still have time here in the video. All right, and this is the sun. You can see the little diagram they have, the sun, they call it solar radiation. Look at how they do this. See the solar wind, right? It's kind of sweeping. I've shown this to you myself, the solar stereo A and B and the sun's kind of pattern there, and it shows you it kind of in a whirly pattern, it kind of like a propeller. type. So that's sort of what they're looking at, that it's sort of pulsing out. Boom, 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 boom. Right? The sun it's beating. That's the best way to put it. You look at the sun, it's kind of pulsating. And so that it's sort of pulsating in that rhythmical torus kind of shape. All right, that's hard to explain, but that's what they're showing you. Here, the winds moving this way, right? Like rotationally. And then you have coming out at us the solar radiation, solar cosmic rays. That's what they're showing here. The modulation of the atmosphere transparency. Then you have kind of energy coming down here, modulated solar radiation. And then you have in this box, it says optic acoustic transformation in atmosphere. Okay, well, that's what's fascinating us right now. This is what we're looking at. The optic acoustic transformation in the atmosphere. That's a bomb, essentially. Variations of absorption solar radiation, formation of thermal unstable oscillations, infrasonic fluctuations in atmosphere. Schematic diagram of connection of a solar infrasound in the atmosphere with solar activity. So, and there's more things. I'm trying to think of other things that it would, like other than a bomb or something like that. But that's essentially, a rocket blowing up. We're what, a factory blowing up, a tanker car blowing up. Okay, that people ask that. Well, there you go. Yeah, there's a study. Yeah, I mean, I might not even be able to remember too much of this, but yeah, there's a study here. I'll give you the link to it. Yeah, I did a video on that. 30 minutes of me chattering on about something I just barely know something about. Yeah, that's familiar. That's what I do here. Oh, on that cheery note, onward and upward. All right, so that good place to pause at that place. Let me refresh. Okay. The solar activity changes results in modulation of global cosmic rays. The modulated flow of GCR during interaction with the bottom atmosphere changes its transparency by formation of aerosols and variations of small compounds of atmosphere. And that's NO2, H2O, O3. O3 is ozone, etc. The changes of the optical transparency lead to spatial variations of the solar energy absorption in the atmosphere. As a result, in various zones of the atmosphere, the temperature gradients and thermal instabilities inducing acoustic fluctuations are formed. Ew. Thunder without lightning? That's what I would say. Heat, thunder. The heat. I'm not sure what the other name is. There's another fun name, but lightning, thunder. That's caused from heat. It's just generated, boom, and it's the thing. All right. The formed infrasound can influence the fluctuation of the intensity of space beams, yep, interaction with atmospheric aerosols. Okay. In figure 2, the introduction of reverse connection is shown. The infrasonic fluctuations can strengthen modulation of the transparency and the effect of optoacoustic transformation in the atmosphere. Okay, I wish I had a picture example of this to give you. We're looking into this, we're researching. According to the proposed diagram of the infrasound generation in its spectrum, the solar action should be shown. Okay. All right, there's a fun chart. I'm not sure what we're looking at there. I will read it to you here. Figure 3, the spectral density of solar activity in infrasound is shown. The data for the period of 97 to 2000 was used. The realizations of infrasound recordings were centered, also smoothed. The index F10.7 was used for SA evaluation. Spectral densities and SA are well coordinated with the range of periods of 24 to 35 days at higher frequencies. The seismic activity more likely influences FA. Okay. All right. We had 24 minutes. Connection of seismic activity with infrasound in the atmosphere. The second factor that significantly influences IFA is the seismic activity. All right, this is where we start getting to the meat of stuff. The influence of seismic activity on IFA is a complex process and does not consist only in piston-like radiation of oscillating lithosphere plates. It is necessary here to take into account the various physiochemical processes both in lithosphere and in atmosphere. The IFA can be caused by gas release from lithosphere cracks during increase of solar activity, oscillation of lithospheric plates, aerosol heterogeneities in the atmosphere. The IFA can create alternate stresses on the Earth's surface and penetrate at significant depths in the lithosphere. Penetrating into lithosphere, the infrasonic fluctuation influence the speed of the movement of fluids, telluric electric fields, and also on local seismic fluctuations. Such processes occur on the large territories and can render the essential influence on seismic activity. Thus, the infrasound in the atmosphere can be both a result of seismic fluctuations and also actively influence them. The character of the interchange oscillatory energy between lithosphere and atmosphere can indicate the processes of preparation of large earthquakes. Okay, earthquake prediction, right? To investigate the acoustic channel of lithosphere-ionosphere connections, two indexes of seismic activity were introduced. First one is proportional to the square of the maximal magnitude in the given day in the given region. The second to the square of the sum magnitudes of all seismic events with magnitude 3 to the third for day in the given region. Two regions were considered, one with the sizes longitude 10 degrees east and then latitude 35 north, and the second, longitude 10 degrees east and latitude 20 degrees north. The first and the second regions included the basic zones of the increased seismicity of Central and East Europe and also Turkey. The infrasound was measured at the point coordinates 40 degrees north and 26 degrees east. The connection of seismicity of the infrasound for the period of 97-2000 was analyzed. The spectral characteristics, infrasound, and seismic activity agrees well. All right, so that's what they're showing you here, how the red and the black agree together. All right, it's fun to have the charts here, but I really don't know what they're showing me. I mean, I kind of do. I read through this. I don't know what they're showing me, quite honestly. All right. Okay, I wanted to show you this, right? Of all the stuff, I'll just read this really quick. Active acoustic experiments in the atmosphere. In the in the atmosphere. The important, hello, can we do this? The important research direction of the connection IFA with processes in geospheres is the artificial acoustic disturbance of the bottom atmosphere and subsequent observations of the change of various geophysical fields. For acoustic disturbance modeling, the large ground explosions were used. Large ground explosions. In such a way, the researches on the influence of ground acoustic disturbances on ionosphere were carried out. The converging facts confirmed the influence of ground explosions on ionospheric plasma were received. However, recently, many researchers put under doubt the possibility of the acoustic wave passage at ionospheric heights. They doubt not the fact of the acoustic wave's influence in troposphere on ionospheric plasma, but only the direct passage of the acoustic wave into ionosphere. Again, the question of whether or not it shows up on the Schumann resonances is, what is the effect on the ionosphere? Simple. Okay, so that's it in a nutshell. Almost at the end of this video, it's like we finally got to the point of what I've been saying. Is it appearing on the ionosphere somewhere? I can't always answer that. I don't know. But that's at the heart of whenever you're asking me, oh, will it show up on the Schumann? Will it show up? What's it doing on the ionosphere? Right? Okay, there you go. These are people that are smarter than me, and they're telling you that. The acoustic waves may not make it into the ionospheric level. Okay, so it may be a local phenomena that you're not going to see anywhere else except 25 kilometers around where the explosion in China happened. Okay, for example, maybe 10, I don't know, maybe 5, depending on how big it is. All right. Those doubts are based on the large attenuation of acoustic waves in the atmosphere during these vertical distribution owing to exponential fall of pressure with height. The pressure decrease causes the increase in the wave amplitude, transformation of its shape in a triangular one, and, accordingly, the occurrence of nonlinear mechanisms of energy dissipation. The purpose of the given research direction was the search of possible mechanisms explaining the occurrence of the electromagnetic responses to ground acoustic disturbance and the creation for tools for realizing of experimental tests. Okay. And this is really cool. I don't know that much about it. I'm just going by what I've seen and read here. But it's like, oh, this is neat. They're got 2 acoustic resonators, they call them, for the realize active experiments in atmosphere. All right, so this one is the mobile jammy. Look at that. You see inside it? Like, wow, holy crap, I want one of them. Yeah, I'm rocking one of them. It's basically a mobile home that they can, send some kind of explosion or something. And this dealio, the stable, like that thing looks like it's ready for wreckage. I'm not sure what it's doing, but it's seriously doing something. So, all right. So I just want to show you that. That was like kind of the last thing. I want to make sure to show you that. There's more words and charts, but it's, closer to the end of it. It's time to put this puppy to bed. All right, so, and I think I might make this the thumbnail. It's like, oh, this is really cool. Like, it comes right at the end. It's not clickbait. I explained to you what it is. It's like, oh, neat. Anyway, all right, so, we're at the 33-minute mark, and we're done. All right, so I'm probably going to put this as premiere, and I'm likely also going to do this as a live stream with all the videos strung together or something. I don't know. Who knows? I get options. That's all I know. All right, so on that cheery note, time to end. Thank you all very much for being here, and I appreciate the love and the support. Thank you very much. You all are very wonderful, and just the comments and the love and the support and the dialogue I get with people, that's what makes it worth it. So thank you all for being here. I appreciate everything.